All right, now that I fixed it, I'm gonna take a minute and I'm gonna show you where you should have found your information for today. So I'm gonna share my screen. Okay, some more people jumping in. All right, so now that I fixed it, this is what you should have seen on your Edsby page. What is this? This is 6th period. But again, I always do the same thing on everybody's pages. So if you were confused earlier because you saw a different document, I've taken it down. This is what you should see on your Edsby page. This is the PDF document, the misleading graphs and statistics, and then this is going to be your Word document. And both of these are also uploaded into the gradebook as well, so to make it easier to send it back to me. Okay. So previously we had talked about making predictions about data. Something else we talked about too previously in a different lesson is we were talking about what measure of central tendency would be the best one to use in order to accurately represent our data. All right, so that is about accurately representing the data. So sometimes the news or papers will print statistics, they'll print a graph, or they'll, print a chart. And sometimes, even though what they're printing is accurate, it can be misleading. All right. In the chat, send me, why do you think a news organization or a newspaper would print something to mislead people? You can raise your hand because that's a lot to put in a chat. Why do you think news organizations or newspapers might print something to mislead you? Go ahead, Wyatt.
Okay, so by mislead, do you mean like being like biased?
Yeah, that's another way to think of it.
What they might like be doing is like by misleading you, they could be like trying to convince you to like believe something. So like let's say elections were tomorrow, this is your last chance to get the thing. They might like give their opinion on something.
Mm-hmm.
So and like get graphs or something to show you that don't waste your vote on this guy, put it like jump on the bandwagon.
Right, exactly. Robbie, you had a good idea. You want to share?
Yeah. So like,
Good job, Robbie.
thank you. Okay, so mostly like, let's say someone was like, I've seen this a lot of times in movies, but it's like somewhere where they're like, oh my goodness gracious, there's a bunch of wasps heading into America. Let's tell fake news about this so nobody freaks out or something. And also how, like, let's say on this certain political person, everyone has this like opinion on them that he's a bad guy, and then they can say something about it like he did not eat all of those puppies or he loves puppies, something where it'll influence everyone to think otherwise, and so that they're not having their opinion, they're having others.
Okay, so think of it this way. If you're looking at a graph, all right, and you want to try to convince people that a certain program has gone from costing, say, $2,000, $2,000, and now it costs $3,000. All right, so if you were depending on how you set up that graph, you can make it look like, all right, something is going up dramatically. So if you want to say, oh, you know, they're spending too much money on this program, look how much it went up by, you know, and you can change the graph to make it look like that it has doubled or tripled in size, depending on how you do your increments, whereas maybe it really hasn't gone up that much. All right, you got to be really, really careful whenever you're looking at information, either on the news or in newspapers, because a lot of times there's a bias involved, and what you're going to find is they're going to create something that supports their point of view. Wyatt, did you have something else?
Oh no, I forgot to lower my hand.
That's okay. All right, so I have a video that I normally show with this, that's a TED video, but as I've been reading and listening to news about what's going on with the coronavirus, there was just this new 5-minute clip posted by a website I visit sometimes, talking about how the data that they're showing us for coronavirus and how the number of cases are going up and how this is skewing the data. And I thought, oh, this is perfect for what we're doing today. So, so I'm going to show that to you. It's about a 5-minute clip, and we can discuss after. All right, this is it. Okay. So this is called How Coronavirus Charts Can Mislead Us. And this just went perfectly with our lesson today, so.
Well, this is a video.
Yep, it's a video. It's about 5 minutes.
Okay.
Sorry, guys. 1 second. There we go.
You may have seen this chart since the start of the coronavirus pandemic. In one image, it appears to capture the state of each nation's battle in the global war against the virus. But like all data visualizations, its design tends to emphasize some things and hides others. So here are 4 things we need to know to understand this chart. First, this is not a chart of all coronavirus cases. It's only showing us confirmed cases. That means each line doesn't just reflect the state of the outbreak in a country, but also how aggressively that country is testing people for the virus. Take a look at Japan and South Korea earlier in the pandemic. Japan's outbreak looked pretty small in comparison. But the available data on testing shows us that South Korea had tested vastly more people than Japan did, even though their population is less than half as big. And now, as Japan slowly increases their testing, the outbreak there looks more worrying. It's a good reminder that we can't understand case data without some sense of the testing levels, and that's especially true for lower-income countries where we know their testing capacity is limited. The second thing to know is that the scale for the y-axis on this chart is a bit different from most charts. It's called a logarithmic or log scale. On a typical linear scale, you divide the space by adding the same value over and over. The log scale is made by multiplying a value, in this case 10. 100 times 10 is 1,000, times 10 is 10,000, times 10 is 100,000. That means that there's no fixed amount of space on this chart for a certain number of cases. So the first 100,000 cases take up this much space, and then the next 100,000 cases get just this much. The higher the numbers, the more visibly squished they become on a log scale. So why do it this way? Well, let's take the 5 countries with the largest outbreaks right now and rewind them back to March 17th. On a linear scale, it looked like things were pretty bad in Italy, but the others were doing better. The log scale offered a much clearer warning. We were all on the same path of exponential growth. It's the nature of infectious disease that numbers get big fast, so it makes sense for numbers to get big fast on the chart too. Fast forward a few weeks, and the linear scale shows cases climbing and climbing, while the log chart shows curves that are flattening. As governments have implemented lockdowns and social distancing, the virus is spreading at a slower rate than before, which isn't very visible on the linear scale. But keep in mind that the difference between this dot and this dot is more than 32,000 people. And the log chart tends to downplay just how many more confirmed cases there are in the US than in the other countries. Which brings us to the third thing to know about our chart. It doesn't account for population size. When you adjust for population, really small countries like Iceland and Luxembourg appear to have the biggest outbreaks for their size, which may reflect higher testing rates. The US and China have much bigger populations, so their curves drop a bit. But the size of a country doesn't really affect the growth rate of its cases, and it doesn't tell us much about how much the country is struggling. It just pushes smaller countries up on the chart and tends to hide the fact that the outbreak is especially bad in certain regions of bigger countries, like the state of New York. And the last thing to know about our chart is that the x-axis doesn't plot time by the date, but by the number of days since the country recorded 100 confirmed cases. For Italy, that was February 24th. For Turkey, March 19th. When they're all layered on top of each other, it allows us to compare the trajectory of the outbreaks. But it tends to obscure the fact that the pandemic hit some countries before it hit others. The world watched as tens of thousands of cases appeared in China. Then big outbreaks in South Korea, Italy, and Iran sent a message about what was to come. 2 weeks after South Korea reported its 100th case, the United States did the same. In a situation where actions taken early can have a much bigger impact than actions taken later, time is a crucial factor. And we have to remember that some governments had more time than others.
New York isn't a country.
No, it's a state. What the video is trying to point out that because the most cases are in New York City, that skews the total data for the United States. So there are certain pockets in the United States where there are more confirmed cases and they've had a bigger outbreak than other places in our country. So that, go ahead.
Why was the music so like intense? Like it sounded like either somebody was or like it sounded like something tragic happened and then like they discovered what it was. It just sounded way too intense.
Yeah, so just be really skeptical as you listen to different government officials, and I'm not pointing anybody out specifically. I'm just saying there are different government officials that are using different points of data that the data is accurate, it's just not being put into context. So, for example, the United States, this is something that keeps being stated by lots of people, is that we've done the most testing in the world, or almost the most testing behind China. Well, not untrue. You have to remember that the United States is the third most populous country in the world. And so we have a lot of people compared to a lot of other countries. So even if by numbers we've tested more people, when you get that data and you say per capita or per 1,000 people, we're actually far behind other countries in testing. So keep that in mind, because other countries are a lot smaller than us. The European countries, I mean, so our country has around 330 million people, and to compare our country to a much smaller country, in Europe that only has, say, 10 or 12 million people. I mean, you have countries in Europe that are that have as many people or less than the city of New York. All right. So when you're trying to compare data, you know, you need to compare it accurately. So you're going to hear a lot of statistics, and just because they're true doesn't mean it's going to give you the full picture of what's really happening. All right, so that's just something to think about. So, so statistics, graphs, all of it can be really misleading because people are trying to make a point. So you should always be able to look at what you're given and analyze it and break it down. All right, so I'm going to share with you what today's lesson is so we get started with that. Share screen. All right. So the first thing, so this is misleading graphs and statistics. Just so you know, I have, for the most part, unless you turned it in this weekend, gone through and tried to grade as much as I could and put things in the grade book. If for whatever reason you think that you have turned something into me and you don't see a grade for it in the grade book, okay, send me an EDSB message so I can check on it. Send me a message, say, hey, I'm pretty sure I sent this to you. I don't see a grade. Okay, it could be I missed it and I just need to go back. It could also mean that I didn't get it. All right. I have, as much as possible, been trying to send you EDSB messages and let you know if what you submitted to me was not the correct assignment. Some of you have submitted things back to me, but you've accidentally submitted just the document without your answers. All right, so as much as possible, I've been trying to let you all know that that happens. All right, so this was your bell work for today. And this is just reviewing what we did last class period on making predictions. Okay, so remember, we need to find what percent. So before we can find the percent, we don't know how many people surveyed. So in order to find out how many people surveyed, you've got to add up the numbers from this chart over here. So take a minute and add up how many people did this pizza shop survey. You can send me your answers in the chat.
Not sure, so. I guess it's the end of the year assignment.
All right, good. So there are 80 people that were surveyed for this. So this is 80 people. All right. So out of those 80 people, how many do we know like pepperoni?
35.
All right, so
35.
we've got 35. So remember, we're dividing 35 out of 80 people like pepperoni, right? All right, I keep saying this over and over again. You are dividing the top number by the bottom number in your calculator. Okay, if you are doing this, you should not be getting an answer greater than 1. You should have a decimal. All right, who got the answer? Who was able to? Very good, Kylie. Kylie, go ahead, tell me, what was your answer?
I got 0.4375.
Thank you. All right, so this is what we get. All right, so that's just our decimal. Remember, I have to move my decimal point 2 spaces to the right to write it as a percent. Most of you did a good job with the ones that I've been able to grade. All right. For B, what percent reported cheese or veggie? So if they give you two options, you need to add the cheese and the veggie people together.
Mm.
All right, so after we add up the cheese and the veggie, get 27. Correct. Justin, what answer did you get?
I got 0.3375.
Okay. And then we're moving the decimal point, just 2 spaces. All right, so quite a few of you came to see me during office hours because this is the part that you were not quite sure about. So this says out of 400 people, how many would you expect to say their favorite topping is cheese? All right, so in order to complete this problem, you have to figure out first what percent of people out of the 80 like cheese. So you're going to divide 15 by 80 first. And the reason we're dividing 15 by 80 is because 15 people like cheese out of 80 people. You're going to get a decimal, 0.1875. All right. You do not want to change it to a percent at this point. You want to multiply it times the 400 because we're trying to find out how many people do we expect if this is what we get. So if we multiply 0.1875 times 400, what are we going to get? Justin, what'd you get?
I got 75.
Right, so we would expect, based on our data, that 75 people of the 400 would prefer cheese. All right, so the lesson today, again, we're going to be looking at different charts and graphs. So look right here. So it says that graphs let our readers analyze data easily, but can sometimes be made to influence your conclusions by misrepresenting data. The 3 measures of central tendency that we covered is mean, meaning the average, mode, meaning it occurs the most often, and median, which is our middle number. All right, so we're using those measures of central tendency to determine which of our graphs might be misleading for us. So if you look down here, all right, so these are lunch prices from 2010 to 2012 at a particular school, maybe, I don't know. So look at these 2 different representations, okay? Which, if you're just looking at it, you're not really analyzing years and data, if you just look at it real quick, which of these makes it seem like the yearly lunch prices are increasing the most? Go ahead and send me your answers in the chat. Which of those graphs makes it seems like lunch prices are increasing the most? All right, if you can, one more second, send me your answer in the chat. Does graph A or graph B make it look like lunch prices are increasing most? Chloe, why did you say graph B? All right. Guys, you can unmute yourselves if you need to. All right, so a lot of you are telling me graph A. Why would you say graph A? All right. Guys, look at this. All right, well, Chloe's right. Chloe said that it was graph B because it looks like the images get a lot bigger. You're trying to determine, it says, which of the following graphs could be used to indicate a greater increase? So if we look just at graph A, the prices are, if you're looking at the bar chart, it doesn't look like it's going up very dramatically, right? But over here at graph B, the sandwich doubles, and then it looks like it's tripled from the first sandwich. All right, so that makes it looks like it's increasing much more dramatically. All right, so I'm not sure why a lot of you thought it was A. Okay, because that doesn't make it look like a very large increase. And in actuality, the lunch price has only increased about 75 cents. But over here, you know, it makes it looks like it's tripled in price. All right, so you gotta be careful when you're looking at the data. All right. So if we look at the next one, or on the second page, says use the table to answer the following questions. All right. So first we want to find the mean, median, and mode. If we're going to find the median first just rewrite your information from least to greatest. And in this case, we only have 5 pieces of data, so it's pretty easy. So you're gonna 89, 3026, 3190, 3315, and 3375. All right. So what's my median gonna be? Now that I've rewritten the data, what's my median?
3190.
Okay, so my median, okay, middle number, right? There's your median. Do I have a mode? If
No.
none of my numbers repeat, do I have a mode?
No.
No. So and remember, not zero mode, it's no mode. All right. Now, if I want to find the average, I'm going to add up all my numbers. So if we add up all our numbers, all right, so all of the numbers added together give us 12,995.
And then you divide it by the number of how many numbers there are.
Correct. So then we're going to divide by 5. So now, once I divide by 5, what is my mean going to be?
2,599.
Yep. All right. So based on this data, okay, and this goes back to a previous lesson, right? When we were talking about the best measures of central tendency, all right? Which measure of center would be misleading?
The mean.
Mm-mm. You think it's the mean? Why?
I don't know.
The medium?
I don't really know why, but I think it might be median mode. I don't know.
Well, there's no mode, so we're not going to use that at all.
Oh, yeah,
So
sorry.
it's got to be median or mean. All right, so which of these, so remember what we talked about, what made things misleading, all right? Notice that most of your numbers are in the 3,000 something, right?
Yeah.
So what do we call the 89?
An outlier.
An outlier, right? So if we use the mean, so the mean is misleading, right? It's misleading. And that's because, remember when we talked about measures of central tendency and outliers. So 89 is an outlier. Remember, if you have a piece of data that's much lower than the rest or much higher, it skews your data. So knowing that, which measure of central tendency would be best to use?
The median.
Yeah, you're going to want to use the median, right? That's a better reflection of the rest of it. All right, let's go look at one more. All right. So they give you 20 days of book sales over here. Okay. And shorten it up a little bit, I'll give you some of the data because I did it ahead of time. So it wants you to find the mean, median, and mode. All right. So first of all, if we're going to find mean, the total number of books sold in our 20 days, so our total is going to be 350. I already added it ahead of time. And then if we're ordering our information from least to greatest, okay, so 0. All right. Was somebody able to come up with the mean, since I told you what the books add up to? These are book sales per day. This is for a total of 20 days. Yeah. Justin, what was the mean that you got?
I got 17.5.
Correct. So your mean, you would have done 350 divided by 20 to get your 17.5. All right, now looking at your data, what's going to be your median? When you're trying to figure out your median, all right, you have two even numbers, or you have an even number of data points. So you have to take those middle two numbers and average them. So what would be the average of 16 and 17?
16.5.
Yeah, there you go. So 16.5. So this is, so your median is going to be 16.5. And then what is your mode when looking at this data?
23.
23. All right. Now looking at this data, which value would most accurately describe your data? What would be wrong with using the mode to describe your data?
It's showing the most,
Yeah, why would that not be the best one to use?
because if it's not showing like the what's in the middle and how much equally it would be, then it's too high
Mhm.
because it's only showing the most of it. It's not showing throughout all.
Okay, so 23 is significantly higher than our data points around the mean and median. So that's probably not the best measure to use. So knowing that, what would be the best measure to use, the mean or the median? Do we have outliers in this data?
Yes.
Yes, we do.
Okay, so if we have outliers, do we want to use the mean?
No.
No.
Right, so remember, if we have outliers, do not use mean. So therefore, the best and most accurate would be to use the median. All right. 0 is an outlier. 36 is an outlier. We take those out, and then the data is not spread out significantly if we take out those two data points. All right. All right. All right, so that's what the notes for today. This is the homework portion down here. And again, and I posted that on there. So your assignments for this week will be due on Friday. All right. Remember, I have office hours every day from 2 to 3. And then Friday with our new schedule, 9 to 11. And so does Mr. OJ too. So you can come see either one of us during office hours. Do we have any questions? We're very quiet today.
Sure is.
Are we tired?
The first for me. Yes, I'm kind of tired because it's Monday, because I have 4 more days until it's the weekend, and I have 2 more of those until
I
it's
sit.
abruptly the last day of school.
I sit.
always tired, actually.
So yeah, and I've been doing yard work all week, so that's fun.
Same.
I've been eating
You've been eating.
Lucky.
yeah,
I
because I'm bored.
I know. You're bored, right? You keep eating.
Stop
I
eating.
just didn't go to sleep till 3 in the morning.
My husband keeps buying me gummy bears.
Stop eating because you're bored. Eat because you're hungry. If you eat because you're